ITEC320 Mini-Lecture deals with exceptions. Now, as we've seen, if we want to input an integer and output it, we would use code something like this. And then we can compile and run, and whenever I get the input, that's fine. Now, if I were to make a mistake, our program finishes and essentially throws an exception and does not print out the value. Now, we can, if we bound our code in a begin and end bracket, we can use the exception clause that says when a data error happens, then we want to output something that says enter a number, not text. So what this will do is, if there is a problem with this statement, then if it is a data error exception, then it will take care of this for us. So if I do 5, program behaves as we expect. If I type in test, well, it will tell us to enter a number, not text, and then outputs the value of I. Now, I did not initialize the value, so let's rerun this and see if this takes care of it. So what this will do is this will protect us from having to worry about what the problem is. We have to be careful to put the code that causes the exception and the handling of the exception in a begin and end block. We need to do this because if we don't have the begin and end block, essentially the rest of this code may or may not be triggered depending on the exceptions there. So you have to make sure it's enclosed for this to work properly. Now there are more than just data errors. For example, there are constraint errors. So if you enter a number that is not in the range expected, then this particular case will catch that. If you have an end of file that you reach when you're still expecting to read something, that's when you can use an end error. And there are the ability to catch everything to say, say you get an unknown exception, you can do unknown. And I may be asking, what would an unknown exception be? Well, like types, Ada allows you to declare your own exceptions. So I'm going to call this my exception, and its type is going to be an exception. And when so in this case, whenever I throw my exception, whenever my code works, it will catch that. So what I'm going to do now is I'm going to raise my exception. And this will forcibly cause this exception to be triggered. So we get a hello world because I triggered it, and when it was raised, the get did not execute. Now, I could raise something that I haven't declared before. nice thing is, in this case, testing is undefined, so it won't work. But if you, in this when others case, if for some reason I didn't put a constraint error in there, or a when constraint underscore error, the when others would catch that. So with exception handling, unlike in Java where you have try-catch blocks, you have just one block that contains the try and the catch all together. So you begin a block of code, and then you have your dangerous code that could potentially raise an exception, and then you have your exception handler at the end, and then you specify the end of exception checking here, and then you can use code that does not need exception checking. Now you very well could write a program that has an exception handler at the very bottom of it, that way it never throws an exception. Or you could use a function that would read an input per se and would return 0 if everything was fine, or return a -1 if there was an error. So there are many different choices that you can make with exceptions, because in this case I'm just doing put line, but as I mentioned that other example with the function, you could easily return something different. So you can create your own exceptions. So if you run into an error case in your code, or when a particular condition happens, you can raise saying, go handle this particular case, and your code knows that something happened. So there is a demonstration of exceptions in Ada.